This is Hector. Hector is a student at MIT. He's a rower, an obsessive learner, and he's the CEO of Lucid, a company that's going to save people like my grandpa by making a device that will detect cognitive decline in your brain. It's a company that doesn't exist, at least not yet, because Hector is just 20 years old and still in school. But in 1 week, he'll be flying here, along with his co-founder Ryan, and 60 other engineers, artists, and founders. And they'll have 6 weeks to turn their ideas into a real product with real users, and maybe an excuse to drop out. So how are two kids used to building out of their dorm rooms gonna do this? To answer that, we have to ask the people who've done it before.
Inference.net is the largest distributed network of GPUs in the world. When I started Inference, I wasn't sure that it was going to work. The idea of using someone else's GPUs to run AI models seemed a bit far out there, but it's working. I don't even know how many developers at this point, 10,000, something like that.
So Sam's company takes computers from all over the world, millions of sleeping latent GPUs, and connects them to power things like model training or the algorithm that recommended you this video. When he talks, I want you to listen to his goal, what we call a North Star for his startup.
Compute cycles are a finite resource. We don't have unlimited computers, we don't have unlimited compute in the world yet. It just seems wasteful to have computers sitting around not doing anything. Those computers could be contributing to scientific research, protein folding, curing cancer. My goal is to make sure there's not a single wasted compute cycle on the planet.
And knowing that goal is extremely important. His company doesn't set out to fulfill the most pull requests or transfer data the fastest, because his customers might not even want those things a year from now. If those were his goals, his decision making as a founder would be based on something that could be irrelevant in the future.
The world will change, the GPUs that we orchestrate will change, but our goal, no matter what, will stay the same. Make compute accessible globally. And no matter what tomorrow brings, that's what we're going to be focused on. Before you start a project, you should know if it's a passion project or a business. A business has customers and you're solving a problem for someone. Make sure there's someone who actually wants to pay for what you're building. You should talk to at least 10 people who you imagine would be users. But a passion project is something you do because you're passionate about it. And maybe the worst thing you can do is talk to people.
WOMP is the world's largest, WOMP is the world's largest playground for 3D design. Got it. When I first started out WOMP, my goal was to democratize 3D. I was a designer, it was really difficult for me. I wanted to melt things together the way I do in real life when I'm using clay. But we quickly realized that a lot of the fundamental concepts of 3D were very difficult in their essence.
So Gabby has built one of the largest cloud-based design tools in the world, and it works very different from her competitors. Traditionally, 3D software is based on meshes, a bunch of triangles that have to connect to each other perfectly to make an object. So you can't bend or morph things easily without breaking them, which is part of why 3D software is so difficult for beginners to learn. So to make it more accessible, Gabby decided to go in a different direction. God, this is such a stupid fucking visual.
There was a specific type of geometry called SDF, which we call liquid 3D. And that is what was the most intuitive, also satisfying way of building up volumes.
SDF is short for sign distance field. Instead of triangles that are defined by specific points in space, objects are made out of points that are dynamic, defined by their relationship to each other, if that makes sense, which gives them the ability to do this. It's way more complex than traditional meshes, and to add to that complexity, WOMP renders live ray tracing as you're designing it, and everything renders straight from the cloud. So even those without beefy computers can still use it. So why the f did Gabby do all of these things that no other company feels the need to do?
It was very challenging at first, and it took us a while to get started, although I was very clear from the beginning what it should look like or what it should feel like. Any other company would never have mixed live ray tracing with editing, especially not on the cloud because of how computationally intensive and heavy it is. But because our goal was to democratize 3D, we knew we needed to do it even if it made no sense to everyone else.
To Gabby, these features weren't detours or extra add-ons. They were necessities to make her vision work. As a founder, you're gonna make a lot of decisions. Some of them are gonna be trivial, some of them are gonna be massive that will determine the entire direction of your company. And you can waste weeks of work and millions in runway on things that do not matter. But knowing your goal, having a clear and defined North Star, makes your decision-making easier, even if it means building something insanely complex, expensive, and with no real proof that it'll work.
And I got actually a lot of hate mail from people in the graphics community who were thinking that this was like absolutely insane because it violated all of the beliefs around graphics engineering. It didn't make a lot of sense to a lot of people that we would do that, but it ended up being one of our stickiest features, which is to actually see this beautiful image that you can manipulate. The founder of Figma said to me, the most important thing, not just in you, but in your teammates, is to be self-aware, reflect on what you want and why you're building a company, why you get up every day to do what you're doing, and try to reflect on who you are and your behavior, because it will not just dictate what you build today, how you interact with your team, what team you built, and what company you'll end up building.
Perfect.
Digital metal will be the fastest way to get cast metal parts like this in the world.
So Connor is trying to build a massive automated metal factory. Here's why. Companies that work in things like aerospace have no cheap way of quickly prototyping or replacing large metal parts, like the giant blades on this fan. Normally it takes weeks to have things custom made and shipped to them. So Connor's solution is to build a giant factory filled with hundreds of robot arms, a massive furnace, and a CNC machine the size of a warehouse that will act like a giant 3D printer for metal parts. But right now, instead of building that, he's making tiny parts by hand.
The first thing we did is we bought a bunch of jewelry equipment because we don't have the money to go and buy like industrial equipment. So we had to start really small. And so we bought things that cost $150 on Amazon to start making our parts. In a perfect world, if we had gotten all the money that we needed and just went out and built this massive factory, we would have run into so many problems because we didn't have our process down. We had to optimize and iterate. Like our first parts, they look good, but they have so many different flaws. You couldn't ship these out to our core customers. And we would be spending all this money without understanding from first principles how to build this company the right way.
By working on this mini version of his factory, Connor is able to iron out all the kinks before he scales up. He's working with just a few people, week by week, and figuring out what their needs are, what their problems are, and what an ideal solution would be for them, so that he'll understand the needs of thousands of other clients before he tries to go and work with them.
We want to be the biggest and fastest metal casting foundry in the United States, shipping 1,000 tons of parts per week. Where we want to get to is that someone can just go to our website, upload their step file, then we automatically generate all the profiles and everything, all the parameters. We make their part and we ship it to them in less than 24 hours. That's the ultimate goal. Right now we're at 72, but we're getting there. I think the most important thing for us long term is that we continue to learn. So this is like a 2,000-year-old manufacturing method, but there's still things to innovate on every day. And that means there's also a ton of previous knowledge and expertise that we can go and learn from. Pretending that you know everything and that you're the smartest guy in the room is never going to be that helpful. So it's really important that you go talk to people who have done similar things in the past, learn from them, learn from their mistakes, and continue to iterate upon their innovation and innovate yourself.
Do you have any advice for the next cohort? Like, what would it be?
I mean, straight up, I think that I honestly believe this. I think there's a huge amount of alpha in just waking up early. All these Silicon Valley people, they roll into the office at like 10, 11. Just wake up at 8 a.m. like a normal person, get to the office by like 8:30. You're gonna be so much farther ahead of everybody else. Your day starts earlier, you get so much more done. That's my number one piece of advice.
Beautiful, perfect. All right, that's it.
Figma Play is building anti-drone drones. Something simple. Yeah, this version, it shoots out of this launcher that we built, and the arms are supposed to withstand all of this G-force, so it can maneuver around like an FPV drone, but it's aerodynamically shaped like a projectile. Quadcopters are really good at hovering and just maneuvering around, floating, being very stable for camera angles. And this is going to be flying more like a plane, like little drones that are flying around, warheads on them, what have you. And we're going to be intercepting other UAVs,
So Carter and Yehor are building drone interceptors. Basically, it'll shoot up into the sky, unfold into a drone, and then guide itself into an incoming UAV. Their belief is that for the world to find some kind of peace, defense needs to become so inexpensive that offense just doesn't make sense anymore. It'll cost too much to fight a war. But right now, defending against an attack costs $4 million per round. Their drone will cost $50K. But nothing like this has ever been made, and they built the first version just 2 months ago in a 24-hour hackathon. So how do they go from that to something you'd trust to keep you alive?
the best functioning devices have the most iterations. In the past 28 days, we built nearly 5 versions and 50 prototype iterations. The key is a feedback loop. Complete the feedback loop. You have some idea of how you're going to solve a problem. You build that with a design, print it, assemble it, and then you test this. And ideally in the test, it breaks or it succeeds. And that completes the feedback loop when you go, okay, how do we change this? And then you do that, and you do another design, and you continue. That's the loop.
And the most important part of this loop is the testing. It is so easy to want to perfect what you're building. I don't want to share my videos until they're 100% done. Maybe you don't want to deploy a feature until the UI looks absolutely beautiful. But if we wait until we think it's perfect, we won't discover all of the millions of problems that everyone but us will see. We like to think of the loop like this. Get the fuck out of here. Build, test, collect data, and iterate. For Carter and Yehor, testing means launching a rocket. For you, it might mean sharing your project online or with 10 people you know, even if it really f***ing sucks right now. The better and faster you get at this loop, the higher your chances of success are.
It's better to have like 30 different tests than one test in our case. Or we're not over-engineering the solution to actually like start prototype. We just make small, gradual improvements over and over time, but it's what makes it better.
It takes a really long time. Like, I've been designing these things, trying to make startups for 8 years, and it was that long fight that just went on for so long, and eventually you do it, and you're like, the habits got me here. And so the advice is to continue and don't stop.
If you made it to the end of this video, for starters, thank you. You're f***ing awesome. I wanted to make this because we're about to invite a lot of youthful builders to our space, and they're all trying to become founders. I wanted to share with them some advice from the people in our community who've done it before, whether it's hyper-successful leaders of industry or a couple of guys who were just in their shoes. We kind of covered some high-level concepts that are important to being a founder. A lot of it is some cornball shit that you've probably heard before. Really, there's nothing that a single video and some platitudes could do to prepare them completely. They're about to go on an insane journey, one with many wins and catastrophic losses. Every one of their journeys is going to be different. Ideally, it's pretty f***ing awesome, but most of the time, it'll be devastating. So, how are 2 kids, used to building out of their dorm rooms, gonna do this? Well, I guess we'll find out.